Students, we're going to be doing a lesson on triangle guts, and you could either watch with the teacher live or you could be following this video. If you're following this video, you need two pieces of equipment. Some sort of compass. You want to make sure your compass is relatively stiff, and you need some sort of straight edge. Now, each video example will have two portions. One in which I tell you to simply watch. It'll take just sometimes 45 seconds, maybe minute and a half tops, but just watch and observe carefully. And then I will tell you to follow. When I tell you to follow, that's when you get out your compass and your straight edge. Watch and follow. Step number one is you are on this page 5 in today's handout. Here you go, page 5. First, just watch. Watch again. What we did is construct two midpoints. Construct using a straight edge and a ruler. Now you're going to follow. I also showed you two different methods. One where it's the traditional, what's called tilt and drag method, and the other is paper twirling. So now you're going to follow. At the top of this paper, a median, you're going to fill this out, connects a vertex to an opposite midpoint. Vertex to midpoint. To construct a midpoint, you put your compass on an end point here. You open it up so it looks like it's just past the middle. Then you don't hold it straight up and down. It's a tilt and drag a long arc. Do not change the compass setting. Go to the other side. Tilt, drag, long arc. You have 2 points of intersection. Using your ruler, you line up those 2 points of intersection. Where it crosses the line, you're crossing at the exact midpoint. There's a midpoint. Let's do it again down here. I'll use the paper twirl method for this one. So you can see both. Again, open up your compass just past the middle, plant it, tilt, and twirl the paper. You can go to the other side, tilt, twirl the paper. You want your arcs to intersect. Straight edge. Where that crosses, that is a midpoint. Hatch mark, hatch mark. That is how you construct a midpoint. Now we're going to construct a centroid. Page 6. First, you're just going to watch. Just watch. What I just did was construct what's called a centroid by creating two medians. Now you're going to follow. Now you're going to follow. So step number one, a centroid is the intersection of the medians. So we're going to construct two medians. Remember, medians connect vertex to midpoint, vertex to midpoint. So it says right here that we're going to construct the midpoint of PQ. We're going to label that midpoint S. So to construct that midpoint, you plant your pivot on one endpoint. I'm going to plant it on Q. And you open it up so it's just past what looks like the middle. And then tilt, drag. I have a big arc. Go to the other side. Tilt, drag. If you've done this carefully, your arc should intersect. Put dots at those points of intersection. Get your ruler out. Where those intersections cross the line, put a tick mark. That's your midpoint, and we're going to call that point S. That is a midpoint, so it's a hatch mark. Now we're going to construct a second midpoint of PR, going this way. We're going to label that T. Again, you're just past what looks like the middle. Open up at the end point and it's a tilt drag. I'm going to use the twirl method here. One of the rules is you never, ever, ever erase your compass markings. Tilt drag. We have two little points of intersection. You should see them. Line those up. Find the tick mark where they cross that side. Double hatch mark. That's a second midpoint. That's called T. Now, draw in your two medians. R to S, vertex to midpoint. Q to T, vertex to midpoint. Those are medians. They cross at the centroid D. And remember, basic rule of thumb, keep in mind that this is a 1 bunny hop, 2 bunny hop proportion. Now, read the bottom of the paper, solve for these two problems, and then check your work and go on to the next page. Page 7. Page 7. Just watch. Do nothing but watch. We're going to construct an altitude. Just watch. We've just constructed two perpendicular lines. Now, follow. An altitude connects a vertex to a right angle on opposite side. So you need to learn how to do a perpendicular line from an external point. So our external point is point R. Plant your pivot point on R. Open up just past the opposite side. This is a smiley dimple dimple. So ready? Sweep a smiley. You have 2 points of intersection. Go to one point of intersection, sweep, another point of intersection, sweep. Your two arcs should cross, and you use your straight edge. Line it up with that external point, and you have made a perfectly perpendicular line. Let's do one from P again. Pivot, ready, sweep, smiley, dimple, dimple, point of intersection, straight edge. You have a perfectly perpendicular line. Now we're going to use smiley, dimple, dimple to construct an altitude and what's called the orthocenter. This one, you're going to follow with me right now, step by step. The orthocenter is the intersection of the altitudes. So we're going to construct an altitude from point B to side AC. We're going to label that point of intersection J and create an altitude B to J. We're going to do that first one together. So we're going from point B to AC. We're going to do an altitude, which means a right angle, not a midpoint. The way you do that is you get your pivot point on B. This is very important. You draw just past the side, like just a couple millimeters. Waiting for you to catch up. Now tilt, smiley. If you look carefully, your smiley has 2 points of intersection there, or should. Now, if your smiley goes off the page between the dimples, you can choke up. Just don't change the distance between the dimples. the dimples keep the same distance. So go to one dimple, sweep, go to the other dimple, tilt and drag, sweep. This point of intersection, you line it up with B. Go all the way through. Now you have an altitude, and that point of intersection is J, and it makes a perfect right angle. So B to J is now an altitude. Now we're going to construct an altitude from point C to side AB. Label the intersection K. So you have an altitude CK. So we're going from C to AB. Follow. Put your pivot on C. You open up as if you're going straight across until you are just a tad past the line. Just a tad. Just a little bit, couple millimeters. Now, smiley, dimple, dimple. So smiley. We have 2 points of intersection here. 1, 2. Dimple, dimple, smiley, dimple, dimple. I have a point of intersection way out here. I get my straight edge. Makes a perfect right angle. That point of intersection is K, and that's another altitude. Where they cross is what's called an orthocenter. And we're going to call that orthocenter R. We're given these 3 measurements. BAC is 40. BAC, we're told, is 40 degrees. ACB is 60 degrees, and CBA is 80 degrees. Find all possible angles in this diagram, then check at the board. The next 2 are kind of fun. There's something really amazing that happens for the next 2. So first off, just watch. Now, follow. We're going to do perpendicular bisectors. So step 1, pivot at the end, just past what looks like the midpoint, and it is a tilt and drag. Oh, let's fill this top out. A perpendicular bisector is a segment which is perpendicular to the side and bisects a side. So we have a tilt and drag, other point, tilt and drag, 2 points of intersection, right angle, and it is going through the middle. It's a bisector. Ready? For this one, I'm going to show the twirl method. You are following now. Just go just past what looks like the middle. And sweep. Other side. Sweep. You get 2 points of intersection here. Perpendicular bisector. Perpendicular bisectors. Now, looking on page 10, there's a special point where perpendicular bisectors cross. It is called the circumcenter. Is the intersection of the perpendicular bisectors. Now you're going to follow me. Follow step by step. We're going to construct the perpendicular bisector of PQ at the midpoint S. So first we're going to create the perpendicular bisector of this line, not the median, even though it's the same construction. Open up what just looks past the midpoint, and this is a sweep arc. Sweep arc. Line up these 2 points of intersection. You're not going through the vertex this time. You're just drawing a perpendicular bisector. And I'd like you to take it all the way through, right angle, perpendicular, and this is midpoint S. That is a perpendicular bisector. Now we're going to do a perpendicular bisector of PR. And we're going to label it with the midpoint of T. Ready? Compass. Put your pivot on R. Open up just past the middle. And sweep. Other side. Sweep. Get 2 points of intersection here. If you've done it correctly, you should see those 2 points of intersection. Straight edge. Very important. Go right through those points. And that is the midpoint T. Where they cross, we're going to call that point U, and that's called, in parentheses, a circumcenter. Now, why is it called the circumcenter? This is so cool. Watch. Circum means around, like Magellan circumnavigated the globe. That means he sailed around, or his crew did. He didn't quite make it himself, but his crew did. And so we are going to circumscribe a circle. Watch, this is so cool. Put your pivot on the circumcenter. Put your drawing point on P. Now, it's better if you twirl this. So I'm going to fold my paper back so it's a little bit easier to see. There's my circumcenter. Put your pivot on P. Now watch what happens. It is so cool. If you've done this accurately, let's see. Call me over if you did this as accurate. Let's see if I did it. Ready? Through P. Now twirl. Da-da-da-da-da. Go through. Twirl. Keep twirling, keep twirling, keep twirling, keep twirling. Da-da-da-da. Oh, look at that. Now look very carefully. If you did this correctly, you will go directly through all 3 points. Boom, right on the money. That's why it's called a circumcenter. It allows you to draw a circle perfectly around a triangle. Why would you need to do that? Well, in draftsman compass, there are car parts, which consist of triangles within circles. And you want to get those car parts directly on the inside. And you do that, the draftsman would do that using a compass. Page 11. Just watch. What we have done is created two angle bisectors, constructed two angle bisectors. Ready? Now you follow. An angle bisector cuts the triangle corners in half. The way you do that, it is a smiley, dimple, dimple. Smiley, dimple, dimple. You put your pivot on the end point, and it really doesn't matter how far you open the compass as long as it cuts across the arms of the angle. So, sweep, go to one dimple, sweep, go to another dimple, sweep, points of intersection, and you just created a perfect bisector of an angle bisector. This one down here, you're going to see you have to, I'm going to show you the twirl method. You're welcome to follow along. You have to choke up the compass so it actually cuts across the two arms. You have to shorten it. And I'm doing the twirl the paper method, which is fine. There's your smiley. Go to one dimple, twirl the paper. Go to the other dimple, twirl the paper. You have a point of intersection where they cross, and line that up. Boom, you have yourself a perfect angle bisector. Never erase your compass markings. Here's our last page. This also creates something super cool as well. The in-center is the intersection of the angle bisectors. We're going to construct an angle bisector of QPR. So trace Q, P, R, and we're going to construct an angle bisector of that blue angle. So at P, put your pivot. Doesn't matter how far this is open, and it is a smiley, so there goes a smiley. Go to one dimple, dimple, go to the other dimple. You're going to get a point of intersection out here. Line it up. And angle bisectors, I always go through the opposite side because I want to de-emphasize this point. This is not a midpoint here. It's an angle bisector, which means your congruency is all the way back there, two congruent angles. Now, we're going to construct an angle bisector of QRP. QRP, so we're going to construct an angle bisector of that angle right there. Right there. Doesn't matter as long as your pivot crosses both arms. So it is a smiley. Keep track of your dimples. There's one dimple here, one dimple there. Ready? Go to one dimple. 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 Smiley. Dimple, dimple. Line it up. Once again, that is not a midpoint. Instead, it's a bisector back here. It's an angle bisector, an angle bisector. They cross at something called an in-center, so we're just going to call it I. Why is it called an in-center? Well, remember, circumcenter allowed us to draw a circle around. Now, we're going to draw a circle in. Watch very carefully. You put your pivot on I. Now, your compass, you don't want to imagine a straight down line from I going straight down. And you want to open up your compass so the pivot's here and your drawing point's straight down on the side. Okay, so it's right there and straight down. Okay, see how it's touching and it's straight down? Now, this works really well if you simply twirl your paper. So I'm going to choke that up. And ready? Twirl. Oops, tape got in the way there. Let me try this again. Stay. Twirl your paper. Twirl, 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 twirl. Ta-da! And you see, if you've done this correctly, that circle is going to exactly touch the triangle on three sides inside, but be inscribed, that means inside the circle. And that's why the intersection of the altitudes is called an in-center. One last thing here. You are told that QPR is 40. QRP is 80. And RQP is 60. Knowing that these are angle bisectors, find all possible angles.